everyone. Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited for this one, diving into SWE-bench and all these amazing works that have come around it, SWE Agent and the latest paper, SWE-bench Multimodal. This is such an amazing series of works around benchmarking how well large language models, large language and vision models now, these compound AI systems, agents, how well they can perform software engineering tasks. All sorts of interesting details around this, such as graduating from, say, just, leet code style programming challenges to actually making GitHub pull requests and solving issues on real repositories. There's just so much to this. I'm so excited for this podcast. So really excited to be welcoming the co-first authors of the series of papers. Firstly, John Yang from Stanford University. John, thank you so much for joining the podcast.
Yeah, no problem. Thanks so much for having us. I'm really excited to be here.
Awesome. And super excited to also be welcoming Carlos Jimenez from Princeton University. Carlos, thank you so much for joining the podcast.
Yeah, thanks so much for having us.
Awesome. So could we kick it off with the story? I love just kind of knowing the intro story of how these projects begin. What led you both to create SWE-bench?
I'll let John take it away if he wants to.
Sounds good. Yeah, we can kind of alternate. So this is I think our 1 year anniversary for the release of SWE-bench was a year ago. But basically last summer, Carlos and I were both around Princeton. Carlos was a PhD student. I wrapped up my master's, but I was kind of a research associate for the coming year. And we had both kind of knocked out our projects from the spring semester. And it just so happened, it was really funny. We kind of thought about the same idea at the same time. I think for Carlos, it was a pretty long boil. You can correct me if I'm wrong, Carlos, of he had thought about this idea of pull requests being a really interesting source of data a while ago. And I had just done this previous work called Intercode, which was kind of exploring interactive coding and thinking about sort of the really basic version behind sort of agentic software engineering. And so we kind of coincided at a good time. But yeah, we were just, we thought of the idea, and I think it was pretty intuitive from the get-go. It took us a day of brainstorming, and then we were kind of off to the races. So that's how it started. Yeah.
Yeah, I think maybe a lot of hackers, developers, I'm guilty of this myself, have tried to take on some project like this where you try to, I think we're all thinking, how do I get my project into some sort of agent system? And so I guess that's the first question I want to ask you about is the original SWE-bench, 12 popular Python repositories, things like matplotlib and these different things. How did you how did you first think about, I guess, the data schema? I want to say, how did you start ingesting the code repositories? Thinking about the data problem.
I'll hand it to Carlos.
Yeah, that's a good question. So I think, so kind of John was talking about how we both were just around Princeton during the summer, and we came up with this idea together. And yeah, I think for the first week or two, we were just pair programming a lot of this stuff. And so all of the kind of initial collection and setup was really just both of us working on everything. And I think it was one of the things I was really interested in was that language models had started to kind of lengthen the context window a lot. So right now, 100,000 is kind of the norm, but back then that only Claude had that, and there weren't really a lot of tasks or benchmarks that really utilized it in an interesting way. There eventually came a few things that became interesting, Needle in the Haystack became kind of interesting around that time. And there were some other things that came afterwards. But at least one of the things that I was very interested in was essentially just how whether you could just, have more interesting long context problems. And so we thought about, could we just give a whole code base to a language model and see if it can solve bugs in this entire code base. And that was one of the original settings of SWE-bench that we tried it out with. So
I guess maybe building on my question, my thing is, even if I give it the entire code base, I'm always tempted to say I should also prompt it with some sort of structure about the symbolic structure of the files, or maybe that's in one of the readmes in one of the folders. And so I guess that's kind of, so I think that's one angle is super fascinating, is long context problem. We're just going to give the entire repo file by file in the input. And then there's also maybe this idea that it, is kind of like a vector database problem potentially, where you define some schema for the files and you have some schema around the structure of it. So I guess I'm thinking. So was the thinking long context? I know in the paper you also have say BM25 retrieval baseline. So yeah, I'd really love to just further understand like how you think about representing a code file in a a repository in a database.
Yeah. Okay, cool. Yeah, we'll do the alternate. Yeah. Just kind of. Yeah, I think those are all really good questions. Yeah, I think we kind of for the original SWE-bench paper thought about just doing like the quickest, easiest thing, and that kind of was what led us to the BM25 retrieval. But yeah, a lot of these questions we had thought about like while we were constructing SWE-bench, and then we did like a more intentional answering of it with when we did SWE Agent. But yeah, I think like and even now, like after SWE Agent came out, like within the past couple months, like if you just kind of look on the SWE-bench leaderboard, you're just seeing this sort of cascading effect of a lot of approaches that fundamentally use language models, and then some identify as agents, like with SWE Agents. Some of them are sort of more pipelined approaches. There's a lot of questions, a lot of angles I think people are exploring. So to kind of bring it back to what you originally kind of asked, in terms of just like how do you navigate a code base, or how do you do kind of localizing the bug, and like what is the form of the code base that's easiest to work with. I think some people have tried sort of the pipeline methodology where you do kind of a lot of pre-processing of the code base. You turn it into some vector store, or into like a more compact representation where like with Python, you kind of pick out all of the classes and functions and you organize them in a way that's sort of very digestible for the model. That's certainly an angle. I guess really jumping ahead with like SWE-bench Multimodal, we kind of explore some of those differences a little bit. But for SWE Agent, me and Carlos, the approach that we took was we tried to offload as much of the sort of problem solving or thinking or intelligence or navigation of the code base onto the model, and just focus on sort of like how do we make the interaction as smooth as possible. So this is our approach. Like certainly other approaches are great, but yeah, in the grand scheme of things, I think it's kind of cool to see like how a lot of people are tackling that problem in different ways.
Yeah, amazing. And I think maybe just continuing to roll along, I'd love to know about the interface you mentioned then, because I guess like that's why I think a lot about the data schema for representing a repo file, because I also feel like that's heavily entangled with how I'm going to define the interface for the language model to read code files or search code file or edit. I think edit is going to be a really interesting one, and things like dependencies, you edit one class, but it's used by 20 others, especially as it gets to be a really big code base. So I guess, maybe if we could then roll along into the interface and and like maybe the retrieval APIs is how do you think about that?
So I think the interface, so when we first built like something like SWE Agent, we're obviously approaching it primarily we're designing it for SWE-bench type of problems. And those are naturally all going to be Python like problems. And I think when we kind of like John was suggesting, when we designed it, a lot of the interface is very kind of agnostic to the language. And you could certainly do more things that are like language specific approaches, or more kind of integrate some of the structure of like the actual like different types of programming languages into how language models can search for search code bases or do other things before they edit. And I think that just at this point, we still have to kind of maybe build out more, I guess, more infrastructure for agents. We have a lot of like this infrastructure for like VS Code and other things, but they're not maybe totally suitable for agents quite yet. We'll see when eventually they become more suitable. But I do think there's like a lot of, kind of a lot of work, I guess, to integrate, the wider ecosystem of like programming language utilities to make them more suitable for like agents to use out of in computers and stuff. And so for retrieval kind of things, yeah, we again with SWE agent we take a very just a very simplistic approach, I guess, where we just try to really just in a way just kind of see how well language models can navigate code bases and make edits in like as simple a kind of interface as possible. So we haven't integrated a lot of retrieval kind of components quite yet, but I think that I think there's definitely people and tools that you can kind of ideally just like maybe kind of plug into the interface so that language models can maybe use those retrieval tools as they as they kind of find useful.
So then is the prompt something like you can semantic search, you can see all the contents of a file, and by the way, there are these 200 files, and then also say like command K style, you can look up this particular keyword. Like if I'm searching a function and I want to say like where does write data live, so it's like, is that the set of reading the code APIs?
Yeah. So, I think kind of going off of continuing what Carlos said, we kind of started off with like the most basic thing. So, before there was some work like that would just take the language model, connect it directly to a bash terminal, and then you can imagine you would just use like simple grep or kind of find commands. And then Carlos tried this out, and I think like on our first iteration, we just found out that this kind of straight up bash search was fairly fragile in the sense that if you look up a term that's like occurs too many times and your context window is flooded, or if you look up a term that doesn't show up at all and you just get like an empty response, then the language model doesn't know if it's just an empty response or if it's an error. So a lot of things like this. And so like that's kind of what led to this sort of agent computer interface idea that we push in the paper itself, which is just suggesting that potentially there are these like principles around sort of putting together good interactive interfaces. And search is very much kind of like one of those settings where we saw like if we evolve the tooling or kind of the input-output interface like against these set of principles that like you can sort of get better performance on the downstream task. So specifically it turned from, well, it's just a raw grep command to, oh, it's a search, but then you're kind of like paging through the search results one at a time, which we actually found out was worse than the original grep search because if you have 50 search results, you're like paging to the 37th one and you're losing all your good context, and we arrived on the summarized one. So without getting into the nitty-gritty, I think like the upshot of all of this is even since SWE-agent was released, I think it's been nice to kind of see some works pay a little bit more attention to this side of things. Like, Claude today just kind of announced their computer control capabilities. And then you have other people like Agent S, like is a new one. Like basically from a lot of these submissions, we're just seeing people kind of mention like, oh, if you kind of, freeze the language model and just kind of focus on what the interaction looks like, whether that's like better tools or like better documentation for the tools or like, just like, is it a Docker container? Is it like a virtual machine, the setting? Like these, tend to have sort of a big effect. And in terms of sort of improvements on the whole AI coding system, it's just a little bit of a quicker feedback loop right now. Yeah.
Yeah, well, I guess something that interests me tremendously is just like I work in little Weaviate things in the podcast. So one thing we're doing is we're working on generative feedback loops, which is like we use the LLMs to update the data stored in the database, and so maybe like going through the code file and enhancing the doc strings and that. And so I'm very curious about that idea of improving the performance of the agent by modifying the data instead of say the design of the agent or the model itself. And that's just one little nugget of that I really like. But I really wanted to continue, mentioning Anthropic has today. I think they call it. I just blanked on what they're calling it. I think it's like computer
use.
Yeah, something like that. Yeah, computer use. Nice, that's a great name. And I love Cursor. I think for me the biggest thing about Cursor is probably the Command K editing. That's probably what I find myself using the most, more so than autocomplete or even kind of chatting with the code base. And I'm just curious from your experience with, equip the building software engineering agents, just maybe if you have a quick take on what the future, like how, what's maybe missing from AI integrated with IDEs and this kind of thing.
Mm-mm. Yeah. Yeah, it's very interesting. So I've been using Cursor, which like clearly it is like, very similar like GitHub Copilot, but in general, like all of these kind of AI tools are really, I think, pretty neat and fun to use. Um, I think one thing that maybe is interesting more about like the computer use of like Claude's new approach, or what I think probably will be the direction of like a lot of new ideas, is just the idea of like just giving the language model kind of more control, or like giving the AI a little bit more autonomy to kind of, as opposed to just saying like, oh, you know, what's wrong with my code? What's wrong with this function? Or like, can you explain like, oh, how do I add this functionality or something? I can just say, hey, I think you can do a little bit more kind of a little more autonomy, where language models can maybe do a few actions like together, as opposed to just kind of making code suggestions. And so I think that's like definitely the direction we're going in the very near future. I don't know how it's going to look, farther in the future, but at the very least, I think we're just going to be maybe taking, a few more steps towards more language model autonomy, in terms of like them having, they can kind of maybe run their own tests, or like integrate, like maybe open different files and kind of do multiple file edits or something that they haven't been doing quite as much. So yeah, I think that's kind of the direction. But
Maybe even, I think there's a huge topic now into the agent design and all the components of it. But I really quick, just kind of hammering on the details. I want to understand, how do you think about editing multiple files? Like, how is this interface to the language model? Does it? Yeah.
Oh yeah, I'll let you continue that one, maybe Carlos, if that sounds
okay, sure. Yeah, I mean, I guess it's not like radically different from um, how they might do it now, right? Like you can kind of imagine pretty straightforwardly how like language models could, ingest multiple files and try to make edits across different files to integrate those APIs. I think maybe the harder thing is kind of just communicating to users like what their model is doing, right? Because like now we kind of have, if we have language models like running commands and editing multiple files and opening data or something, like I don't know. I think that's you have definitely have to kind of let models kind of, or sorry, let users get used to having a bit more trust of language models, and then also you will have, I assume, like whatever framework is providing this, you want to be very like serious about avoiding mistakes, and like you have to kind of earn that trust in a way, I suppose. But
Yeah, I guess that makes me think about like how I work with my team at Weaviate, where you review a pull request, and I guess it's kind of, there is definitely a lot of, I guess I'd say, trust in it, and I guess I would even say personally that I'm not super far along in my career of being sort of a professional software engineer where I'm super great at this, but so I wouldn't say I'm like the master at reviewing pull requests, but from my experience, yeah, I'd definitely say there's a lot of trust in it. I guess like I can imagine, like you have to have a lot of knowledge of the code base to easily read this, like you have 5 files changed and you just look at the difference, and that's like how you read a pull request, I guess, is
yeah,
currently how you would do it. And so I can imagine these language model pull requests, they come with an amazing description, whereas right now it's maybe not so much, and like each change is probably super well documented. And yes, I guess I'm just curious about maybe, yeah, like how you think about the future of software engineer. I guess this maybe has like 2 questions in it, but maybe the future of like reviewing AI pull requests. I guess like, because kind of in this question could also be like imagining, does this run overnight? Is it just running constantly? AI agents doing some type of research and then like opening pull requests.
Yeah, that's interesting. Yeah, I think I think one of the other directions that you're very much touching on, which I think is cool, is very much this kind of like collaboration aspect to it. And sort of for like different use cases, like what does that intervention or collaboration even look like? Yeah, because I feel like from just a general software engineering field standpoint, it's a little bit hard to answer that question for all of software engineering. But then looking at things like QA or deployment or sort of graphics or like specific sub areas, I think then you can answer these questions in a bit of a more meaningful way, which is like very much exactly what you touched upon. Like Carlos and I have definitely had the luxury of kind of talking to a lot of people since SWE-bench and sort of getting different perspectives from different interested parties with respect to like what use cases they want to apply SWE-agent to. So just as like a general kind of anecdotal thing, like maybe a company is more interested in kind of real-time monitoring and they want something that can, do diagnostics or like, if there's an error, like it can kind of develop that error summary or that stack trace really quickly. So for an agent like that, like you probably want it kind of running in the background like a daemon process. And then when stuff comes up, like it's automatically able to sort of look around and put together sort of a diagnostics report. But then you might not want the agent to actually act on it. Like then you want the person to be the one to carry out the fix because maybe there's more accountability there. Even just kind of like we worked with Shunyu while at Princeton, and there was a big React paper, and just grounding it in that. Just some people might like to be the ones to tell the agent what to do. Some people might like to get suggestions from the agent on what to do, and they would rather be the ones coding out the action. So it seems to us that there's just a lot of dimensions, a lot of different sort of ways you can look at collaboration and sort of understand like how people want to collaborate. And I think it's probably a pretty nuanced answer in the near future, maybe not the far future. Everything is just agents eventually, but yeah.
Yeah, yeah, everything is headed to that fate.
Yeah.
Yeah, so yeah, I guess I'm thinking I'm just like lost in imagining this kind of flow of like how you might have a pull request and you kind of review it and you're saying no, or I'm also just thinking about the interface of you open an issue and it triggers a GitHub Actions or something that maybe that's what kicks off the agent pull request. Maybe that's a part of the future interface. That's something that I could imagine being pretty seamless. And then when you're reviewing the pull request, you say, "Oh no, I guess do it like I like to see it with like a red black tree." I don't know. I'm trying to remember some kind of like efficient data structure concept. But I guess kind of one other aspect to this that I want to ask about is like the use of external tools and how important it is to SWE agent that it is able to, like, if I want to use the Hugging Face Transformers library, say they just add something new and I want to go have it use some external library. So kind of maybe coming into like the guerrilla work from Berkeley and this kind of perspective of thinking about using other people's software tools and just how that gets orchestrated and kind of like the data system this might require. And so I'm curious if you have an interest in that kind of concept.
Yeah, no, I think that's definitely very interesting. I think so. When we first developed SWE Agent, like I say, we were kind of focused primarily on very simple interfaces. I do think like as these things like AI agents, like SWE Agent was, building off of intercode, like one of the, these were kind of very early like language model interacting like with a real kind of computer, going back a year or so. And clearly, like with Claude's, especially like with Anthropic's new release, and I'm sure we're going to see more and more of these types of things. I think there will be a lot more kind of community interest in getting language models to use all different types of like tools and like and get used to like different types of workflows. Every company has their own tech stack, and I'm sure like the different kind of configurations of agents are going to reflect that. And so when we were building out SWE Agent, we had this very simple design, but I think that definitely there's going to be like you can kind of configure these agents with their own like by installing your own software and like exposing tools to them and kind of giving them some, their own documentation or, tutorials on how to use all types of, tools to achieve different types of problems. So there's another paper that John and I helped with that actually tries to do this with like more um, that essentially tries to build and integrate agents for solving like capture the flag tasks, or like capture the flag um, challenges. And in that kind of case, like the configuration that was used for that agent has to do like kind of GDB and debugging and more like different types of like all these very specific different tools that were not necessarily like well supported or included in like the first configuration of SWE agent. And I'm sure like every new iteration of like I say, every company has their own tech stack. Every like application has its own type of programming style, and things are going to be configured in a lot of different ways in that sense.
Yeah, I think that's such an interesting one of like like setting up the like Kubernetes deployment and things like that, where it's quite different from the typical programming task, and they've got the and I guess it is kind of a bit tangent from the capture the flag type of thinking, but coming back to kind of like the tools the agent has access to, and I'm really curious about these like kind of like long running agentic processes, and I'm really curious about the run times that software engineering agents can execute their code in, because you probably have to have some type of thinking about, I guess maybe it's like a Docker container or something, and you're like saying you can allocate, this much amount of memory, this much amount of CPU to each unit test, or however you're thinking about that. So you say, I just love to know how you think about the allocation of, I'd say, compute as a tool to a software engineering agent.
Yeah, yeah. This is Carlos and I have put a lot of thought into this. Like, because when we did SWE-bench initially, we just trusted that Conda environments were good enough for reproducibility. And then, like, I think this year, January, right, Carlos, we just found out we were totally wrong, and that you need you need Docker containers. And I think, like, I think like credit to when OpenAI collaborated with us to do SWE-bench Verified earlier this summer, like one of the big contributions, like, the curated data set, I guess, is the one that gets more sort of Twitter publicity. But, certainly like the Docker, the sandboxing, the containerization of evaluations was huge. But to kind of bring it back to your point, yeah, certainly just sort of like resource allocation is in and of itself a question. The nice thing about the SWE-bench benchmarks is for original SWE-bench, like all of the repositories are PyPy packages. For SWE-bench Multimodal, they're all JavaScript, like kind of node projects. And so what that means is that from the execution kind of resource standpoint, all of the containers are like pretty much like the same size. Like the biggest container that you might have for like a multimodal task instance is like 10 gigabytes, which sounds like a lot, but it's really not, like just sort of in terms of how everything is installed. But yeah, I guess we've seen like a lot of cool projects. Like I'm sure there's going to be people who try to extend SWE-bench in terms of evaluation, or extend SWE Agent in terms of making sort of better coding agents, which we've already seen. So yeah, to your point, along both of these directions, I think more difficult tasks or more long running agents that have longer windows or kind of have like more diverse interaction spaces, or even just like the workflows or the procedures that they do are a bit more long horizon than just sort of greedy as is right now, will certainly entail like having the right environment and having kind of the right context, whether that's like just code base as a context or like the machine and the compute resources as a context. So it's something, I guess TLDR is something we're actively thinking about. And I'm sure like, I think this question that you asked is like great. I feel like it kind of touches right on the sort of the heart of a lot of the academic research being pushed right now for agents.
Yeah, yeah. I think I do think there's so much to this topic, so I'm trying to find the right question to kind of steer it in. But yeah, I guess I'm very curious about. I like it almost like just. I don't know if this is the best thing to say next, but just thinking out loud, it really reminds me of the neural architecture search stuff and how you'd have like this hyperband algorithm about like unequal resource allocation to different promising architectures, and maybe there's this kind of thing for different solutions, but then there's also sort of this, like if you're just allocating agents to solve any issue, you maybe have to have some sort of prioritization, and then you probably have like merge conflicts. And as you mentioned, you need to update the environments to be using the same version of the library. And so I guess the question, I mean, I think that was a perfect description of that. And so I guess I just want to also ask about, yeah, like if you thought about sort of like scientific computing, like GPU resources, and then I'm also kind of curious, like if we love modal at Weaviate, and I'm curious if modal helps with this, because modal does kind of simplify the creation of, like, the auto scaling of resources, the creation of these images. And so I'm just curious if maybe tools like that have come into your view.
Yeah. So you kind of brought up, I guess, a couple things, including like particular resources for like assets for certain environments where, like maybe a language model could have use for like GPUs. I think the most like famous or like interesting, I don't know if interesting, but it's definitely one of the most kind of well-known applications or settings for this is essentially like language models maybe doing machine learning kind of workflows or like research kind of stuff. And so, there's recently been a lot of interesting work around essentially things kind of like SWE-bench, but more for like, training language models, kind of training their own AI systems, or, maybe self-improving their own kind of code bases or stuff like this. And so, and in those cases, they might need a GPU so they can like run some model on those GPUs and kind of do what like very, I guess, do similar tasks to what like their own like programmers of like ML engineers would actually do. And so we haven't experimented. I guess we haven't done, like, there's definitely a lot of cool work and interest in that type of thing. I don't think that we've done a lot of exploration of that exactly. You brought up Modal, and Modal I think is very, they're definitely, they have like a very neat kind of API where you can, run lots of things remotely in a way that's maybe a lot simpler than kind of deploying like, maybe traditional kind of remote deployment or something. I think that definitely has some application, and I don't know exactly like what more to say about that, but like I think there's definitely going to be a lot more of these type of containerized agent, settings where people will want to do like, you want to run agents, but I think probably for very good reason, you don't want to let them loose on your own machine all the time. So I think like there will definitely be a lot of kind of like, I know like the computer use mostly, I believe like mostly essentially uses like containers as well. And that I assume that will be like the pretty standard thing for a little while. But yeah.
Yeah, amazing. I think that's just such a deep topic. And I think it kind of maybe even we can transition to our next topic and then also maybe simplify this one a bit, which is talking about the design of software engineering agents. And I guess the first question I want to ask you about is, I see kind of two schools of thought emerging where we have agents, where you have this kind of looping interface where you're connected to functions that you can call. And at each stage it says, hey, would I like to call one of these functions? I have this, knowledge gain so far, or do I finish the response? And in that context, I could see executing code as being one of these functions. And then on the other paradigm, I think we have compound AI systems. John, I think earlier you called this pipelines, and I call these like compound AI systems. And so maybe like the DSPy type of thinking where you write out some flow. Like I think alpha codium is one of the most famous. I know you both have a list of all this, like you've really seen all the designs of software engineering systems. So I'm curious, like just maybe if we could start with that type of way of thinking about like kind of like agents with functions versus you design some kind of pipeline.
Yeah, for sure. Yeah, I think we definitely, I guess it's a little bit of a two-parter. Kind of when we did SWE Agent, we kind of stuck with the more agents that can call functions approach. But in sort of response, we saw a lot of people, at least in the academic community, works kind of like agentless or moteless is also a good one that's open source. And they sort of have these a bit more prescribed solutions. So it's kind of like a two-phase thing, right? Like they'll start with like this localization phase where you process the code base into either kind of a nicer natural language representation, or sometimes they'll just turn it into a vector store, and then like the kind of the query will be the key, and the code files or lines or however granular you want it to be, code blocks, whatever will become kind of the values that you can look up. And then sort of in the second stage, you'll do this like searching/editing process where you're given the store representation. So I think what we kind of saw from like the leaderboard perspective is we put out SWE-agent, and then these pipeline approaches come out and they don't need execution. They're much lower in cost. Like SWE-agent was like $2 something every time you wanted to run to fix an instance. But then for these pipeline approaches, they were like 50 cents or 40 cents or less than that. And they were sort of a bit easier to set up. So no Docker container, no crazy stuff like that. But then kind of that's what kind of prompted our interest over the summer of like, okay, like now it feels more purposeful to just do SWE-bench, but for like a different language, as opposed to before we just do it for the sake of it, to say like, if you have these kind of prescribed solutions that were designed for SWE-bench, for Python repositories, like if I point this at just like another language, another repository, another code base, what problems are going to come up, not just for the procedural ones, but for like all the approaches in general. And I guess like, yeah, that's kind of where our take on like, if you have a procedural approach that's a little bit more tailored, like it works well for SWE-bench, but then you point it at a JavaScript repository and then things start to fall apart. And what those are is kind of like, well, the parser is for Python, or it assumes that the code base looks a certain way, assumes it's kind of like a PyPy project, or fundamentally it assumes it's kind of an object-oriented programming style, when in reality you might be dealing with things that are a little bit more functional or kind of written more procedurally and aren't written as classes and methods. In JavaScript, I think just looking at the way React works, like React introduced like hooks and functional kind of style things a couple years ago. And if you just point this method of looking at classes and methods, like it doesn't quite work. So I guess like that's our latest stance, which we kind of discussed more about in the latest multimodal paper, is centered around this idea that like there's maybe this division of responsibility when it comes to an AI system between the language model and like the scaffold or the agent system, whatever you want to call it, that it's working with. And so some of these agent systems are symbolic, kind of like you mentioned, in the sense that they take care of a certain portion of the problem-solving approaches. But our suggestion is that maybe you don't want to do that, or maybe this approach is good, but then just be mindful that if you're dealing with a new code base or a new setting, there might be more parts you have to rip out or refactor around the language model. So I don't think we have like a strong answer on sort of like which direction is best, but I think it just kind of highlights that this sort of trade-off exists. Yeah.
Amazing. I guess that's sort of, I think the trade-off too is that agents are super general, and that's the appeal of the interface. And then thinking about, I think the example you give is amazing for how you might go about summarizing a code repository for a full stack JavaScript type of thing is going to be totally different from how you look at a Python repository. And these compound systems, they encode these particular strategies of how you learn a code base, and so it makes a ton of sense for why that wouldn't transfer. I guess just one more before we transition into SWE-bench Multimodal, which I think we're already kind of starting to get there. But I'm really curious just about, like, I'm really fascinated with the compound AI systems and sort of coming up with the multi-stage decomposition. And so I'm curious, like, if you've learned anything, like in seeing people design these systems for software engineering. I'm just curious, like, how do people come up with the decomposition? Is it just human intuition mostly, or are these automated like language models to design the pipeline? Is that just like how do people design these multi-stage pipeline systems?
Yeah. Yeah. I think it follows kind of maybe like a paradigm not introduced, but like that something like RAG generally kind of aligns with. So you essentially have you have a whole bunch of like kind of source documents that that could be relevant, and then you kind of want to get the language model to solve a problem within the context of those documents, but focusing primarily on specific things. And so um, I think this is also something that is like yeah, so this general kind of paradigm where you want to like retrieve and then generate based on these types of things, I think is the kind of general structure for a lot of like pipeline approaches. Um, I think the kind of special or like the secret things that kind of improve performance is usually when there's usually kind of it's a little bit more sophisticated in the sense that like you can maybe try multiple searches or like kind of have the agent check the context and then see like I don't know, do some kind of more sophisticated retrieval or something. That's definitely one component. And then, yeah, maybe with like the language model, they can kind of generate, multiple answers and then like, compare multiple, proposed answers and consolidate them and so on. And so there's definitely kind of things around that general framework, but I think that tends to be the general framework that you kind of have like a retrieval phase and a generation phase, and those two things can have some like bells and whistles, but those are like kind of the typical structure. Now, this is distinctive from like the agent approach, of course, because the agent can just kind of do anything, and frequently it does something similar, like the agents will use some search tools or use like they could use a retrieval API or something and try to like find relevant context for themselves. And then they also, do their own edits and generations and so on. And so like, I think the pipeline structure it comes from a place that's fairly natural, and there's advantages to that where you don't have to like, you know, you don't have to set up all this compute environments and like you don't necessarily have to do a lot of complicated like there's definitely complications from agents that make them more expensive and make them like kind of harder to manage. um, but I think what are kind of like kind of what John was mentioning a little bit before is that these approaches can we notice what's different is that because they're a lot less general, they tend to be like a little bit less freeform. They're baking in some solution into like the approach, of course. While that can be helpful, I think it's just important that those solutions are general, right? So like, yeah, you're not super dependent on like Python like parsing or something, or you're not super dependent on like, you know, some maybe I don't know like hardly typed kind of static type languages or something. And so um, yeah, that's kind of like the like what I would kind of mention about those two things.
Yeah, also I think so many cool ideas in there. I just the last nugget about the typing. That's the kind of thing I can imagine that an AI agent reviews a code base and like adds typing to it as maybe one of these like extra documentation things. And then this idea of I kind of like how LangChain introduced this as MapReduce to describe like breaking up the long context into short pieces and applying inference. And then yeah, as we're talking about how do you assemble these components, and yes, I think this would transition perfectly into then so you developed this, amazing benchmark for Python repositories, SWE-bench, and now you've recently extended it to multimodal. I'm so excited about this personally because I love having, like, I am terrible at CSS and things like this. So I'm always using Anthropic and these tools for this purpose. So yeah, I'd love to just kind of hear the story of extending the benchmark.
Yeah, for sure. Yeah, I think when we were kind of discussing like for our SWE-bench extension, like we didn't want it to be an arbitrary, like flag planting thing. We're just like, let's just do an extension and kind of turn in a new paper. So I think we were quite purposeful with like the selection of the language. So certainly, like we kind of mentioned it in the paper, but it's also in the GitHub kind of yearly Octoverse report that like JavaScript is the most popular language used, at least on GitHub, for like the past 10 years running. And certainly like the visual component, I think, is what really sets it apart beyond it just being a different language. But yeah, I think it's like, even kind of when we were justifying sort of the motivation for this whole project, it was centered around this idea that like software engine, like it is called SWE-bench, but certainly in practice, like it captures a pretty good portion of repositories, but there's a lot of other elements of software engineering that don't happen to be captured and very much exist. So yeah, I think that was sort of the general premise. I would say like the main contributions were just demonstrating how one, like sort of our benchmarking strategy works very well and is in fact extensible. Like I think we make this claim in the original paper, and people can imagine that it's the case. But now, like if there are people who want to put together SWE-bench style task instances for their own internal repositories or for other things, like Carlos and I have the confidence that we can actually replicate this formula, like for any interested party, like who wants to do SWE-bench style evaluations for their own thing. And then second is just what kind of you and Carlos were both talking about before, was just sort of like the setting for it. So, we did find that ultimately the agentic approach, at least for now, with SWE Agent, seems to perform the best on this sort of out of domain task where, you're offloading as much of the JavaScript coding and understanding onto the language model, which is capable of from what we know in prior work, and that you're still just focused on like the interaction. And, it's grounded in Bash, so the kind of CLI stuff still works fine for JavaScript. Nothing there changes. But of course, the performance is like not as good as it is on SWE-bench. And so that kind of begs the question of like, how do you actually try to, for lack of better words, climb this benchmarking hill now? And, does that mean like better language models? Does that mean better scaffolds? And we think it's probably a combination of both. But in terms of the scaffolds, like you're seeing like so many companies in the past couple months kind of push out their own thing from kind of cognition. They kicked it off with Devin, and now like every other week there's like a new YC company that's trying to tackle coding. So good luck to them. But I think we would just say that like, yeah, it's important to think carefully about like, is this something that tackles all use cases? Like, I think this is what a lot of companies are pitching, but I think there could be like a healthy amount of skepticism that one should have when evaluating these companies of like, okay, you want it to do everything and anything, but what does that actually mean? What is the setting that they're dealing with? Because I mean, at least for Docker, one thing that we found is if you want to just render websites in the browser, it's not that straightforward. Like you got to do this kind of headless Chrome thing, and there's certainly capabilities that are not available within like certain sandboxed environments, right? So I think like the vision is very compelling, but I think through our kind of because we've been taking this sort of evaluation stance, as a lot of people are kind of chasing the great methodologies, which is really exciting. But from our perspective, it's just kind of like sometimes it's really just the foundation of how these things are built that really dictates like sort of how it grows. Yeah.
Yeah, amazing. It really inspires me thinking about like the business impact of all this. I guess I think about the mentioning the YC companies, and then I guess I think about the I think about like having a website. It's sort of like most businesses have. I'm not sure. Like I think like Wix, Squarespace, WordPress, they all have this visual component. And I guess like I'm almost getting distracted from the technical thing, and I'm thinking about like which domain of software applications has the biggest opportunity for this kind of thing. And this also kind of reminds me of thinking about like modifying Weaviate the database. Like if you have this prior of like, by the way, this repo is for a database, that would probably help you a lot compared to this is a machine learning training framework or something like that. So then and it sounds like you like there's opportunity to find some particular kind of software thing. You start with the agent interface, which is again this kind of like function calling looping thing, and then you zone in on some kind of particular pipeline that you find for the thing.
Yeah.
And I guess like you mentioned quickly, my technical question was, you mentioned quickly that rendering the web pages is difficult, and I'm just super curious about how what I imagine that my Anthropic needs when it's trying to help me build a website is let's see it, how does it use that action of, okay, let's go see what, I guess it's equivalent to, in the Python environment, let's run this code. It needs to see it. So I guess I'm just curious about that see it action.
Yeah, yeah. So I guess the way it works is like normally, essentially, what you kind of do is like, which is something we learned about like when we're doing SWE-bench Multimodal. I didn't know much about this before, but essentially, you can like simulate X windows on like non-deviced, like actually headless containers. So like within a container, you essentially just have like all the pixels simulated on not just in memory, essentially, right? And so I was curious about, I was looking a little bit into the code for the computer use, and this is exactly what Anthropic does too. So like it's like the reasonable approach. You essentially, there's some tools that you can do to like essentially just simulate these types of X windows on in like Linux containers, and that's like kind of the idea. I know you can do some kind of like forwarding to visualize that window from the Docker container locally, so you can also do that. Yeah, so it's very but yeah, that's, you can do stuff like that. So
my knowledge of port forwarding is just as far as I know what the term references a little bit, but I can that I guess that's the kind of thing. Kind of maybe earlier we talked about like Kubernetes and like capture the flag type of things, and I can only imagine that's like really cracked level, like really getting into it. Yeah, so I guess it's also really kind of the extension. I'm really curious now. This is maybe like a future question. I'm not sure if you thought about it before or interested in it, but is this kind of like virtual reality, and I guess like expanding the, like you mentioned, different types of software, like, or like embedded software, and but I guess particularly with SWE-bench Multimodal, I'm really curious because I think that we're seeing Meta is going to take us into this era of virtual reality, and then I think it's going to be AI agents, like the kinds you two are building, that kind of pioneer this new era of software and even teach us these kind of concepts, sort of.
Yeah. It's really fascinating what like the new Ray-Bans can do, and maybe that like kind of coding agents have a role sort of in that ecosystem. Yeah, it's really cool to see. Like, kind of, I think like the short-term future, like we've been talking about, is like, you just do SWE-bench, but not JavaScript. You do it for Java, for backend systems, for front-end system, for full stack, for QA, for games, for yada yada yada. And I think like, depending on sort of how interested the industry is, which it seems like it is right now, everybody will kind of figure out things sort of independently with respect to sort of their area. It'd be really cool to see how that works for virtual reality. Like, having played with it like a little bit before, like I think even now, like, a big use case is kind of games, and a lot of the like virtual reality seems like it's still a very sort of app store oriented experience, where like kind of like on the iPhone, you have independent third party developers building like apps that like have a lot of common ground and a lot of sort of audience. And that could be one way to do virtual reality, but you can imagine that people would really want to personalize their experiences. And even sort of at a more meta level, like we don't even know what kind of personalization they actually want. Like, it could be simple things, just like, your wallpaper on an iPhone, or like if this is something that's really immersive and that we're spending a lot of time in, that you want to do this kind of personalization. But, as sort of someone on the virtual reality team, you don't even know what configurations that person wants, right? So I think there you can imagine like, maybe it's a coding agent, maybe it's like not exactly like JavaScript code, but it's working with some sort of symbolic language. And, there you can, just kind of dream of this like crazy future where like you have something that's like rolling out, coding up the experience for you as you go. So I think this is definitely getting very futuristic. But I agree that like certainly that reality is possible. I think Carlos is definitely trying to convince me of something like this over the summer that VR is the way to go at some point. Yeah. Yeah.
Yeah, amazing. I guess it just kind of it inspires me because I think about how I would need the help of something like this to navigate CSS, and I can only imagine what the virtual reality analog of CSS is going to be. And yeah, I mean, all this stuff is just so fascinating. I imagine it's going to touch everyone who works with software is going to be impacted by this in some way. And yeah, and our podcast was really touched on every topic I can think to ask. So I kind of wanted to just wrap up broadly by asking you both this broad question of just what directions for the future of AI excite you the most?
Yeah. Yeah. So personally, I think one of my probably longest standing interests in AI has essentially just been around concepts of essentially of like automation, right? Like I think doing kind of we have this we I think the future will really be one where these types of tools will provide a lot of like economic value to everybody in society, and I think it's just a matter of like if essentially if we can free up a lot of human hours from labor in doing that type of automation. I think that's something that's just, at least for me, probably the most exciting thing. So
Yeah, that's really cool. And then for me, like, I think I definitely resonate with that. Another aspect is just sort of like the human AI collaboration. Like, I think like a little bit grounded, kind of, we've seen like people make sort of instruction tuning on RLHF and all this kind of like dialogue oriented push of like taking this great base model and turning it into a chatbot that's really, really helpful. But then kind of what feels compelling to me is like certainly the use cases as we're seeing. I think SWE-bench is just the tip of the iceberg, but they'll be kind of more complicated and more involved, and the agent's going to need a lot more long-running context than just like, hey, here's a sentence, rewrite it. And so like if you're going to take a base model or take a lot of these like kind of great strong models that we have and make it work for like hyper specific business specific use cases, like what does that collaboration look like where do they get injected, and then like certainly when you enter the business world there's a lot of like other considerations around just like privacy and security and collaborating with other companies. And so what paradigms will emerge. Like right now I think like we've seen like React is still such like a young paper in some sense, but also really old in terms of AI years. So beyond this kind of like thought action chain, like that as a foundation, like where do we kind of go next in terms of how these things are deployed, and is it a business? Is it interacting with a customer? Are these two things that are proxies for the business that are interacting with each other within the company? I'm sure there's like so much internal tooling that could benefit from this. So I think just a lot of fertile ground for exploring these questions.
Yeah, well, Carlos, John, thank you so much both for joining the Weaviate Podcast. This was an awesome discussion. I learned so much from it. SWE-bench, I mean, Agent, Bench Multimodal, all these works you're doing. Congratulations. It's all so interesting. I'm really happy we're finally done this podcast because I have been aware you work for, I'd say, like it's been, all over the social machine learning sphere. So thank you so much.
Thank you. Thank you
yeah,
so much.
thanks so much.